f is continuous, but I'm asking you the type. So what did I have to verify? Because this very well could have been a whole versus an asymptote, couldn't it? So the only reason why I actually went through the process of adding them together was to verify that I did not have a whole, or I did not have a whole at either 0 or -2. All right. So you select infinite discontinuity at 0 or -2. Any questions on these? We're going to take a look at piecewise functions. Okay. So let's take a look now at E. So when you're talking about a piecewise function and you're talking about continuity, always go back to the conditions that have to exist for continuity. To be continuous, the limit from the left and right has to be equal to the defined value. So when you have a piecewise function, the first thing you want to do is you want to actually look at the functions within the piecewise function. For example, look at 2x minus 1 all by itself. We all know what y equals 2x minus 1 graphically looks like. What is it? Come on. Can you agree with me that y equals 2x minus 1? There are no holes, there's no jumps, there's no asymptotes in that graph of y equals 2x minus 1. You agree with that? If you look at the next function, x squared plus 1, let's talk about that. It's a parabola. There's no holes, there's no jumps, there's no vertical asymptotes. You agree with me? So if this continuity is going to occur, it is going to occur where the domain is restricted. It's going to occur at 0. So that's where you may have a jump. Remember, not all piecewise functions are going to connect. So if this continuity is going to occur in this particular piecewise function, we have to look at 0. So remember, since 0 is where the discontinuity is going to occur, we have to verify that f of 0 is equal to the limit as x approaches 0 from the right, which is equal to the limit as x approaches 0 from the left. Those are the conditions that have to be met in order for this function to be continuous at 0. All right? Because these are the conditions for continuity. So first of all, let's find f of 0. Where do you plug 0 into to find f of 0? You plug it into x, exactly. So when you plug it into the second one. So 0 squared plus 1 is just 1. So again, the limit as x approaches 0 from the right, you're looking at those x values larger than 0. So to find the limit as x approaches 0 from the right, you're just going to plug it in again to where x is greater than or equal to 0, which is going to give me again what? When I plug 0 in for x, that's just going to give me what? 1. Equals. Now you've got to look at the limit as x approaches 0 from the left. When I talk about the limit as x approaches 0 from the left, I'm looking at those x values slightly smaller than 0. So where do I plug 0 into? Into the 2x minus 1 for x. So 2 times 0 minus 1 gives me a what? Negative 1. So is negative 1 equal to 1? No. So again, what's happening is what? The limit from the left is not equal to the limit from the right. So I know that the limit as x approaches 0 from the right of f of x is not equal to the limit as x approaches 0 from the left. So if I was to actually graph this piecewise function, would this piecewise function connect? No, you would have what kind of discontinuity happening? You would have a what? Jump. So I have a jump discontinuity at x equals 0. So always go back to those conditions and always go back to the definition of continuity. Yes? You can graph it too. Yep. If you're not sure what the conditions are, then you could always go back to the picture. Pictures are your friend. You can always graph it. Absolutely. All right. Any questions on that? Let's look at F. Again, it's another piecewise function. So we have x squared minus 1 over x plus 1, where x cannot be equal to negative 1. What is the second part of the piecewise function? It's a point. It's a point. So the big question is, just because if I look at x squared minus 1 over x plus 1, I know if I factor this numerator, what's happening at negative 1? I have a what? Hole. So I know I have a hole at x equals negative 1. So again, if I simplify this, I'm looking at the function y is equal to x minus 1. So graphically, I know that this function looks like this. I have a y-intercept at -1, slope of 1, Graphically, that's what this rational function looks like. Again, that's still in that. So the big question is we can't automatically assume that this is going to be discontinuous at -1. Because the big question is they are giving you a defined value at x equals -1. They are telling you in this piecewise function that -1 is defined. And the question is, does this defined value actually fill in the hole? Well, remember when we graph rational functions, how you find the y value of the hole. At x equals -1, you simply plug in -1 for x. So y equals -1 minus 1, so that gives me a y value of -2. So my hole is actually occurring at -1, -2. So now look at the defined value. Does -1, -2 actually fill in the hole? Yes. So graphically, am I going to have any place where this is discontinuous? No. So this is going to be continuous for all real numbers. It's continuous for all real numbers. All right? So any questions on that? All right? So let's look at G. Again, it's another piecewise function. Is the absolute value of x over x, and again, x isn't equal to 0, and then they're giving you this other defined value, x equals 0. There's an extra x here. Oh no, that's just the denominator, never mind. We want to know if it's continuous with 0. So am I continuous with 0? Well, let's take a look at the graph. So again, what does it mean to be continuous? To be continuous, the limit as x approaches 0 of f of x has to be equal to f of 0. That's what it has to happen. Those are the conditions that have to be met in order for this to be continuous. Well, let's first look at the limit as x approaches 0. So again, I'm just going to take a look at the picture. So again, the limit as x approaches 0, we're going to look to the left and on the right. So let me just start plugging in numbers to the right of x. Let me start plugging. What happens when I plug in 1 for x? Again, I just do that first time. I plug in 1 for x. What is the absolute value of 1 divided by what? 1. What if I plug in 2? What's the absolute value of 2 divided by 2? What's the absolute value of 3 divided by 2? What's the absolute value of 4 divided by 4? What is the y value if I plug in 0.00001? So you agree with me then? Again, this part of my piecewise function, I'm just looking at the absolute value of x over x. Again, it's not defined at 0, but everything is going to be equal to 1. So for all my x values greater than 0, I'm getting outputs of 1. So now to find the limit as x approaches 0, I not only look to the right, but I have to look on the left. Let me look at my x value slightly smaller than 0. So what happens if I plug in -1? Well, the absolute value of -1 divided by -1 will give me what? -1. What happens if I plug in -2? Well, -1. What happens if I plug in -3? -1. What happens if I plug in -0.0000001? -1. Do I even have to go any further? No. Did I fail my continuity test? Yes. So what kind of discontinuity is happening at 0? Jump. So I have a jump discontinuity at x equals 0. And again, the reason is the limit from the left is not equal to the limit from the right. So it automatically, you don't even need to know what that defined value is because it automatically fails. It's not going to be continuous because the limit from the left and right are the same. All right, so any questions on that? Again, if you are not sure by looking at the equations, pictures are your friend. Graph it. You're going to do lots of graphing in calculus. Get used to it. All right, so questions on that. So that's how we know, given the equations, if you know you have discontinuity or not. All right.